Hello class, this is Mr. Henry again with another video for you guys since I am away this week. Today's lesson is on elimination, which is another method that can be used to solve a system of linear equations. I'm sure you're wondering, well, why do I need to learn another method? I already know how to do substitution. And the answer to that is because in some cases, using elimination will be a whole lot easier than using substitution and vice versa. I'm sure you're also wondering, well, will I need to know how to do both on the test? And the answer to that question is also yes. For example, I might ask a question, solve the following system using elimination or using substitution, and you'd be expected to know both of those methods. Before we get into elimination, I wanted to revisit a question from yesterday's lesson, the one at the end that I posted for you guys to try. This one here. So I'll actually solve this using substitution and then get into elimination after this. But I just wanted to talk about how you would solve something like this. Here we have three equations, and we actually have three variables, a, b, and c. And we need to solve for all three of them if we're trying to find the solution to the linear system. Which means we're actually going to have to do more than one substitution. If we look at the second equation here, a plus 2c equals -7, you can see how I'd be easily able to rearrange that into an equation that isolates a. Right? Also, in the third equation, I could easily isolate for b, since everything here is a multiple of 2. It would be easy to divide everything by 2 and have an equation that isolates for b, which gives me two equations that I could use to sub in for a and b that have c as the expression on the other side of the equation. So what I'm actually going to do is rearrange both of these and use both of them to do substitution. So rearranging the first one is easy. A equals -7 minus 2c. Rearranging the second one, I'll just show it in two steps, even though it's also pretty easy. 2b equals 4c plus 20. Divide everything by 2, and I have 2c plus 10. So now I've got an equation for A, an equation for B that both have C on the other side. So if I were to sub them in, that would leave me with an equation that just has C as the only variable in the whole expression. So what I'll do is I'll call this equation 1, we'll call this equation 2, and this one equation 3. And I'm going to, if I write it up here, I'm going to sub 2 and 3 into equation 1. So that will look like minus 2c plus 10. Right, so wherever there was an a, I subbed in -7 minus 2c, and where there was a b, I subbed in 2c plus 10. I can then expand. Collect some of my like terms here. And I'm still working to isolate for c. End up with 28 over there, and then so c is -4. So I've got c, and just like the other questions we've done, we need to find the other variables too, right? Before we've done questions with two variables, so that means one more step. Here I'm trying to find a and b as well, so I'll actually have to do two different substitutions here. So over here we'll say, let's sub c equals -4 into equation 2. Right, if I do that, I can plug in something for c, and then I can find a. So a is -7 minus 2 times -4, would be +8. So that gives me -7. No, so -7 plus 8 is 1. So a is 1. I can also sub c equals -4 into equation 3. Right here, if I plugged in -4, I could find b. 2 times -4 plus 10. So that would be -8 plus 10. So B would be 2. Right. Now these 3 points don't really give us a point on a like two-dimensional Cartesian plane like we normally would. So I'm just going to state my answer all together. I'm not going to state it as a point though. So A equals 1, B equals 2, and C equals -4 would be the answer to this. Okay, so now we'll actually get into elimination. We have a question like this: 4x plus 2y equals 10, and we have x plus 2y equals 1. Now, you might be tempted to try substitution on this and work ahead. I'm actually going to recommend that you just keep rolling here and then watch as I do elimination, since it is relatively new. What I'm going to do here, instead of substituting anything, I'm actually going to perform an operation on these two equations. So I'm going to call this first one 1 and the second one 2, like we would normally do, except what I'm going to do, instead of subbing one into the other, is just do equation 1 minus equation 2. It sounds sort of weird, but what I'm really going to do is just subtract each side of the equation from each other. So on the right, I'll just have 10 minus 1, and on the left, I'll have 4x plus 2y minus x plus 2y. When the equations are lined up like this, it's really easy to do because I'm just subtracting each term. So if I do that, 4x minus x gives me 3x. 2y minus 2y, that is now 0y, so it's gone. You can almost say it's eliminated, hence the term elimination, right? So we've eliminated 2y. Over on the other side, 10 minus 1 is 9. So all I'm left with is 3x equals 9, which obviously means x equals 3. And then I'm halfway done the question, right? Which is a whole lot easier than if I had rearranged this for x and then substituted that into equation 1 and then solved and then subbed that in again to find x. I was able to do this in just 2 steps. Right, and this worked out nicely because I had the same coefficients here, 2y and 2y. So all that's left is to sub x equals 3 into 2. So 3 plus 2y equals 1. Move the 3 over, I now have -2. So y is -1. So my point of intersection is 3 and -1. So that was relatively easy to do using elimination. It would have probably actually taken longer if we had done substitutions. You can see that here, in some cases, elimination will be a lot quicker than substitution, which is why we need to be able to do both methods. Okay, let's look at question B. In question B, I now have a positive 3n and a minus 3n in my two equations. Remember, in a previous question, we talked about how the coefficients have to be the same. Right, so if the coefficients are the same, I can do elimination. But if we look back at that one, I had positive 2y and positive 2y. Right, so if I subtract them, I have 0y. Over here, if I did 3 and then subtracted -3, I would have 6. Right, so I would not actually eliminate n. So what I'm going to do instead is add them. Right, if I add 3 and -3, that is 0. Right, so now I would have eliminated n. So what I'm going to do in this question is, and I'll call this one 1 and this equation 2, I'm going to do 1 plus 2. So 5m plus 3m, that gives me 8m. And as I've just shown over here, 3 plus -3 is going to be 0, so n is now eliminated from the system. And then 19 plus 3, that gives me 22. which means m is going to be 22 over 8, which I can actually reduce to 11 over 4. Right, so I'm halfway done the question. The other half I would do just by subbing this in to one of my other two equations. You can pick either one. Usually it's nicer to pick the ones that have lower coefficients because that means it's going to be a little less work to get the answer. So if I sub that in here for into equation 2, so let's say sub n equals 11 over 4 into 2, then I have 3 times 11 over 4 minus 3n equals 3. And then I can just rework this and solve for n. Right? 33 over 4 Right here, I just created a common denominator of 4. So 3 times 4 is 12. So 3 is the same as 12 over 4. So 3 minus 33 over 4 is the same as 12 minus 33 all over 4. So that's negative 21 over 4. And I move the 3 over as well, so my negatives actually cancel out, so I have 21 over 12, which actually simplifies to 7 over 4. So that means my point of intersection, because I'm using strange variables here, I'll say mn equals 11 over 4, 7 over 4. Right, you might be interested in a slightly different way of solving this. And keep in mind, from here, this is just an equation that has a fraction. So we could have actually just multiplied everything by 4, right, and got rid of that fraction, which would leave me with 33 minus 12n equals 12, which would have been probably an easier way for us to get n. Right, so both of those methods work. What I'm trying to suggest here is that instead of going through this long process and having to make a common denominator, if you're not so good at finding common denominators, maybe getting rid of your fractions before you solve would be an easier step for you. Okay, the next question, question C, I want you guys to try on your own, and then I will put up the answer. But hit pause first, and then once you are done, hit play, and you'll be able to see the answer to this question. Okay, some of you might be stuck here because, well, I've got my 2x and my 2x which line up. I've got this 5y and a 3y which line up, but I don't have these on the same side of the equation. So what I would do here is rearrange this one equation. So I have 2x plus 5y equals positive 8. So that way I know I have something that lines up with each of my terms, so I can do my elimination. You have a choice to make here. Are we going to add or subtract? And the easy way to think about this is, well, which operation would eliminate x? If I did 2x plus 2x, that would be 4x. So I'm not going to have anything eliminated there. If I do 2x minus 2x, that would be 0x. So x would be eliminated. So I'm going to call this first one equation 1 and this one equation 2, and do equation 1 minus equation 2. Right, 2x minus 2x, that is now eliminated. 5y minus negative 3y. Make sure we watch out for our integer operations here, right? 5 minus negative 3 is actually the same as 5 plus 3. So that leaves me with 8y equals negative 9, right? 8 minus 17 is negative 9. Right, the rest of this is pretty easy. Now I have negative 9 over 8 for y. And I just have to sub that into one of the equations to find x. Like I mentioned on the last question, pick the one that's got lower coefficients because that will be a little bit easier. Right here I have a 17, here I have an 8, here I have a 3, and a 5, which are pretty close. I'm going to pick the first equation just because the numbers are a bit lower overall. So sub y equals negative 9 over 8 into equation 1. And then I have 2x plus 5 times negative 9 over 8 equals 8. Now, you can sub into either of these two equations, right? We should get the same thing, and we've talked about this before with substitution, but we're talking about a point of intersection, a point that lies on both lines, right? So the x and the y should correspond in both equations. Okay, so I'll keep going with this. So I have 2x minus 45 over 8 equals 8. I want to make a common denominator on the other side of this equation, so I'm going to multiply this. So I'll have 2x equals 64 over 8 plus 45 over 8. Right, and in the last problem, we talked about how you could just multiply everything here by 8 to get rid of the fraction. Both methods work here. So I have 2x equals 109 over 8, which if I now divide by 2, I have x equals 109 over 16. Okay, and then I just have to make sure I state my point of intersection, which is 109 over 16 and negative 9 over 8. Right, so hopefully the fractions here didn't complicate things too much for you, but the process was the same. I want to think about how we started each of the last 3 questions. We talked about in some of them we subtracted, and in B we actually added, and in A we also subtracted. So there's a bit of a pattern here that you might have noticed. If I have the same sign, if both are positive, then I would subtract. That would eliminate y. If I have opposite signs, then I'm going to subtract in order to eliminate. Now, in both of those cases, the coefficients have to obviously be the same. Over here, they were both positive again, and we have to think about what we're actually trying to eliminate, right? Even though there's a positive and a negative sign here, we're not talking about positive 5y and negative 3y. We're talking about 2x and 2x, which are really both positive 2x. So I'm trying to eliminate these, which are both positive, so I'm going to subtract. So the shortcut to help you remember that is if we have the same sign, for example, if they're positive and positive, or if they are negative and negative, we're going to subtract. And if we have a different sign, like positive and negative or negative and positive, then we would add them in order to eliminate. The coefficients here, like I mentioned, obviously have to be the same or else this would not work. Okay, let's look at a next question here. I want you guys to try question D. Try this on your own. Keep in mind you might have to rearrange here so that we have everything lining up. But pause the video, try to solve this on your own and see what you get. Okay, so for this question, like I mentioned, we want to rearrange. So I have 6x minus 4y equals 12, so that I have all my terms lined up and on the same side of each equation. I have opposite signs here, so I have negative 6x and positive 6x. So I'm going to add. So let's call that 1, and let's call that 2. And we're going to do 1 plus 2. But that's weird. If I have negative 6x plus 6x, that's 0x. But I also have 0y, right? Because I have 4y plus negative 4y, which also cancels out. So I have 0x plus 0y equals 2. Now, let's think about that. What numbers could I put in here for x and y that would make this side of the equation equal to 2? Right? There aren't really any. So this is a case like we saw yesterday where there's actually no solution. Right? Which, as we talked about yesterday and on Friday, that means that the lines are parallel. Right, those two lines will never cross anywhere because there's no values I can sub in for x or y here that would make 0x plus 0y equal to 2. If you don't believe me, you could also try graphing these two equations in something like Desmos and see what you get. But if you do trust me, you'll hopefully see that these would be parallel lines and they will not cross. Okay, let's look at the next question, which looks a little bit interesting. We've got some expressions here with binomials that might need to be expanded. Right, in order to do elimination, it's a lot easier when we have something that looks like this, where we have numbers that line up and terms at the same variable that line up that we can add and subtract. We don't really have that in question E. So what I encourage you to do is expand all of these, and then let's simplify so we do have two equations that each have just 3 terms in them. And that way we can do some elimination. So I'm going to take the first one. We have 4x minus 8 equals 2 minus 2y. And I'm going to move things so that I have my x and y on one side of the equation, and I have my constants on the other side of the equation. Now, if I have 4x plus 2y equals 10, all 3 of those are terms that are divisible by 2. Right, so I can simplify this a little further and just divide everything here by 2. Right, that's just going to give me 2x plus y equals 5. Okay, let's call that equation 1. My other equation, I'm going to do the same thing. I'm just going to expand. So 2x minus 10 minus 2y minus 6. Now, keep in mind that's minus 6 because that negative applies to both terms in the binomial. Right? Just collect some of my like terms here. And I'm trying to rearrange this so I have something that looks like this other equation. So I have 2x minus 2y equals negative 5. Right, and let's call that equation 2. So now I have to look at my two equations and decide which variable can I eliminate. Here I have 2x and 2x, which is the same coefficient, which means I can eliminate x. I can't eliminate y because I have 2y over here and I just have 1y over here. Right, so I can't actually get rid of that. So, and because I have positive 2x and positive 2x, that means I'm going to do a subtraction to eliminate. So if I do equation 1 minus equation 2, I'm going to end up with, well, those will be eliminated, and then 1 minus negative 2 is going to give me 3y. So again, watch out for that That throws off a lot of people. If I'm subtracting negative 2y from y, I'm actually adding it. So that'll be y plus 2y, which is 3y. So I have 3y equals 10, which means y is 10 over 3. Okay, now I need to sub this into one of my equations. My general rule is to pick the equation that looks the easiest. In this case, equation 1 looks easiest because it's got a coefficient of 1 on the y, so I don't even have to multiply that fraction by anything. So what I'm going to do is sub y equals 10 over 3 into equation 1. So that'll be 2x plus 10 over 3 equals 5. I can move this 10 over 3 to the other side. Right, and let's make a common denominator here. If I want this to be over 3, I need to multiply everything by 3. So 5 times 3 is 15. So 15 over 3, which is the same as 5, which gives me 2x equals 5 over 3. And if I move this 2 over, then I end up with x equals 5 over 6. So I have my x and my y now, so my point of intersection is 5 over 6 and 10 over 3. Okay, let's look at a couple more, and then before we move into the practice questions for today. In question F, we're dealing with some decimals, which might make things look a little complicated, but when I see 0.3y and 0.3y, I know that this isn't really going to be that bad because these are going to eliminate, and then I'm going to just have like one decimal and another number that is going to be a decimal. So I'm going to pause, or I'm going to get you guys to pause the video now, and then try this question on your own, and then check back to see what the answer is here. Okay, so I've got the first half of the question done here, and I'll just recap what I did. Since I had negative 0.3y and negative 0.3y, I chose to subtract, right? That will eliminate the 0.3y. And 0.5x minus 0.4x, that's just 0.1x. And then 4 minus 1.5 gives me 2.5. When I went to divide, I have 2.5 over 0.1. Right, if I want to get rid of this fraction, I could just multiply both of these by 10. Right, if I multiply both by 10, then that moves this decimal over 1 on both. So I end up with 25 over 1, which is obviously just 25. So next, I would take that. Let's sub x equals 25 into, and it doesn't matter really which equation you pick, both of them have decimals. So let's just pick equation 2. So 0.4 times 25 minus 0.3y equals 1.5. All right, if I multiply 0.4 times 25, that gives me 10. And I have 10 minus 0.3y equals 1.5. On Wednesday, on the worksheet that we had Wednesday, we looked at solving an equation with decimals in it. And to get rid of those decimals, if this is 0.3, right, which is 3/10, if I multiply everything here by 10, then I can get rid of all the fractions that I have. So if I multiply everything by 10, I end up with 100 minus 3y equals 15. I moved the decimal over here as well as over here. 10 times 10 just became 100. Then I can rearrange this, if I have 100 minus 15 equals 3y, so 85 equals 3y, divide both sides by 3, and I have y equals 85 over 3. Right, so I took a question that had decimals in it, and I was even able to give an answer as a fraction, which is awesome. So now I just have to state my point of intersection, which is 25 and 85 over 3. Okay, so that wasn't too bad. Once I was able to kind of get rid of decimals, it sort of simplified the question. And over here, when I multiplied everything by 10, I got rid of decimals again, and I was able to get an exact answer, 85 over 3. Why don't you try the next question on your own, question G, and then pause the video, try it on your own, and then hit play, and I'll work through the solution. Now, I realize that some of you might be hitting play here because you are just stuck and want to see me solve the question. So what I've done is just kind of put up the first step here to get you in the right direction. I want two equations where the different terms line up with each other. So I rearrange this first one, 2 over 3a plus 4 over 7b equals 4. I mean, I'm sure you yourself can switch these two terms and that a's and b's line up perfectly. And at this point, you might be stressed out because you see fractions. But keep in mind, when we eliminate, we're going to be eliminating 2 over 3a, right? I have 2 over 3a in both equations. Once I eliminate 2 over 3a, half the fractions are gone, right? So try doing that yourself, and then if you're still stuck, I guess you can keep watching, or otherwise, if you get the answer, then hit play and you'll be able to double check that you got the same answer as I did. Okay, so to add these two together, once I add those, the a's will be eliminated, right? 2 over 3a plus negative 2 over 3a will be eliminated. Then I have my b's, 4 over 7b plus 1 over 7b. That's a super easy fraction to add. That's just going to be 5 over 7b. And 4 plus 6 is 10. Now I just need to solve for b, so I can multiply both sides by 7 to clear this fraction, and then I would have 5b equals 70. Right, and then just divide by 5. So b is just 14. Now I need to sub b equals 14 into one of the equations. I'm going to pick equation 2, just because the coefficient here on b is smaller. So let's sub b equals 14 into equation 2. So I'm going to end up with 14 over 7 minus 2 over 3a equals 6. 14 over 7, well, that's just 2. So 2 minus 2 over 3a equals 6. You can move this 2 over to the other side. And just like I did over here, I can multiply by 3, so that's 12. And then when I divide by negative 2, that will give me negative 6. So a is negative 6. Which means my point of intersection, AB, equals negative 6, 14. So that really wasn't too bad. We did have two fractions in the question, but we were able to get rid of one, or one pair of them, because we eliminated it. Right, and then once we were from there, we had fractions, but this equation only has two terms, so that's easy to get rid of that fraction. if you're comfortable with all the questions we've done so far, I've got another extra question like we did on yesterday's lesson that I want you to try. This question here, we have 3 equations again, and we've got 3 variables as well. So try and solve this using elimination. And let's see how you guys do with that. Like we did last time, I'll probably take this one up at the start of tomorrow's lesson. But if you are up for it, see if you can solve this system of 3 equations.